Okay, so the first thing I want to explore is this the good marker? Oh, no, you have a good marker. Is if we can say anything like if 2 to the x minus 3 to the y equals 1, or if 3 to the y minus 2 to the x equals 1. Can we say anything? Okay, so we have some examples, like we have 3 squared minus 2 cubed equals 1, and we also have 2 squared minus 3 to the 1 equals 1, for example.
Well, I mean, the only thing I can see right now from here is that we know that the power of 2 is, the powers of 2 can be either 1 or 2 mod 3.
Ah, okay, so that's a great observation. 2 to the x is either, I'm going to say plus 1 or minus 1 mod 3.
Mm-hmm. Okay.
And we know that powers of 2 can be both of these numbers.
Uh-huh.
Yeah.
Because we can see, like, 2 is minus 1 mod 3.
Alright, 2 to the 1 is minus 1.
And then 2 squared is plus 1. So, we know that we can, the powers of 2 look like they alternate because 2 cubed is going to be minus 1. And 2 to the 4th is going to be plus 1.
Okay, these are all mod 3,
Yeah.
by the way.
It looks like odd powers of 2 are going to be minus 1 mod 3. And
Okay.
even powers of 2 are going to be 1 mod 3.
Alright, why?
Well, because when you know, 2 is negative 1 mod 3.
Huh?
And you can multiply the mods together when you add on another 2.
Okay.
So minus 1 times minus 1 is plus 1. Times minus 1 is minus 1. Times minus 1 is plus 1.
Okay, so what implications does that have for our equations up here, where 2 is the 2 power is the larger one, where the difference is 1, and
So,
the 2 is the smaller one?
Here, this is an even power of 2.
Okay.
And this is, here it's an odd power of 2.
Alright, so it's kind of a surprise. We can even say something right away. If the power of 2 is bigger, this has to be even. Mm-hmm.
Yeah.
Or so it seems. And if this is down here, it has to be odd.
Mm-hmm.
Okay, because I can, if I do everything mod 3 here, I get 1,
And then 0.
0.
So that'd be 1.
Yeah. There was one exception here.
Well, 2 to the 0, 0 is technically even.
Yeah, but didn't we have 2 to the 1 minus 3 to the 0? Oh no, that is 1,
Yeah.
right?
Yeah.
So
So that's
there's
our
one
exception. Because 1 isn't an even power.
Alright, so why did that exception work?
Because 3 to the 0. Because 3 to the 0 is not 0 mod 3.
Very good. So the one exception is when I do mod 3, I don't get 0. So if I do for y bigger than 0, when I do it, I get what?
So you would get 1 because this would be 2 mod 3 and then 1 mod 3.
Okay.
So end up with 1.
All right. So we're gonna have to maybe consider a separate exception where 2 where we use a 0 power here, but maybe actually just to simplify for this, we'll just ignore the 0 power.
Yeah.
Because
Okay.
that won't ever happen again.
Yeah.
Well, let's just ignore it for now.
Okay.
Okay. So let's talk about this case, and then we'll move to the second case. Okay. So if I have 2 to the 2, I'm going to write it now as 2x minus 3 to the y equals 1.
Alright.
What can we say about 2 to an even power?
So it's a perfect square.
Aha! So I'm going to get a perfect square. So I'm going to write this now as m squared minus 3 to the y equals 1.
Well, maybe this is a square.
Okay.
So if this were a square, then we could do difference of squares on it.
Right. If it was a square, we could do difference of squares, but we don't know that that's a square. But we do have something else in the equation that is definitely a square.
This is a square.
All right. So what does that suggest we might want to try to do?
So we could we could maybe take the square root of both sides. I mean, move the m to that side. And then, or move the m to this side and then multiply it by -1.
Okay. Or what's an equivalent?
This over here, this over there.
Okay. So I get m squared minus 1 is 3 to the y.
Yeah.
Okay. And what can I do now?
So that means we can do difference of squares and say m minus 1 times m plus 1 is 3 to the y.
So this is 2 to the x minus 1. So power of 2 minus 1 times the power of 2
Plus 1.
plus 1 is
3 to the
3 to the y.
Well, we could do some things with mods here. 'Cause we don't, x doesn't necessarily have to be even. Because we have...
X doesn't have to be
Yeah.
even, right? Okay.
So x is even or x is odd.
Uh-huh.
So if x is even, then 2 to the x is going to be 2. 1 mod 3.
Uh-huh.
So this is going to be... We can check and see if it's possible.
Yeah.
But so 1 mod 3 is 0. So it's possible if it's even.
Mm-hmm.
And then if it's odd, it's also going to be possible.
Okay, do you see why that's true?
sort of.
If this is an even power, it's going to be congruent to 1 mod 3.
Yeah.
Then I subtract 1 and I get 0 mod 3. So I get this side is 0 mod 3. And that side 0 mod 3.
Yeah.
And then when it's an even power, when it's an odd power, this one's going to be 0 mod 3. So modular arithmetic doesn't work here anymore. We need a different idea. So modular arithmetic says it's possible. But we need a different idea from number 3. What can we say about a number that's a power of 3? Give me an idea about a number that's a power of 3.
Well,
Actually, let's go to the third movie here.